Okay, let me check to see. I've got some sound, so away we go. This is going to be BISS 1123 Part 2, and I promised that we would cover XLS 7. Now, that one's going to be due on the 27th, but we're going to work ahead a little bit. I've uploaded for you an example of what we'll be using with XLS 7. And we'll talk about that here in just a minute. But I want to also make certain that as we look ahead, next on the 27th, you have the quiz over break-even analysis and economic order quantity, and then you have a quiz over FEW Chapter 6. So let's scroll down here for just a minute, and we'll look at the resources for quizzes and exams. All right, now we'll come down here and we saw exam. Here are the resources for the break-even and the EOQ quiz. There's the Badger Jams key, and that's over in the files section of Canvas. Over at the BISS 1123 supplemental website, and the link to that website is up there in the, I believe, in the announcements section or the welcome module. You'll find the following files there or resources. Then we have the hardware nuts. That's in the files section, and got XLS7 best XLS7 hardware nuts done, and the order point for the EOQ model. And so some information there for us, because that deals with economic order quantity. Now, today, we're also going to look at we're going to look at the economic order quantity there in Chapter 81, and we're going to look at the economic order batch, and we'll talk some more about this. So I'm going to go through the example of hardware nuts, okay? And then we will, and I think I've covered it, but I just wanted to reiterate. And then on FEW Chapter 6, it's from the show me the numbers text. Now, let's go on over, and I'm going to take a look at the resources for the cases, all right? And let's scroll down here. The resources for case number 7, and that's the hardware nuts, I give them some names, don't I? That's the example file. And then the practice files out of the Excel companion zip text, the Excel companion content, but this is number 2, and that's a zip file, and it's loaded over there in the files, and that'll get us rolling for XLS 7. So I'm going to go back here, okay, and I'm going to find we're going to find the files. Well, let's start with hardware nuts cool, okay. And we're down here. Here we go. This is an example for XLS 7, and I'm going to download it. I think I might have talked about it before, but I just want to make sure that I reinforce this, because this is also going to have some stuff that's on the exam. I'll show this in my folder, and I'm going to throw this down to my desktop. Okay. And close that off. Let me see what that is for just a second. No idea what that is. Okay. No, it's over. Let's close that off. All right. Now, here's the hardware nuts, and this is a company that was using the economic order quantity. There's a little more meat on the bones here in terms of the example, all right? And I'm going to enable the editing in it, all right? And you'll have it to upload if you care to do that first. Well, it's an example for 7, all right? And this is a company, I don't know what they have. They buy some kind of inventory, so they're going to use the economic order quantity system. Now, I want to show you some things up here, okay? First of all, you're going to see an assumptions area, that's in the purple, the fixed cost per order, which is part of the EOQ equation, and then inventory carrying cost is a percentage of inventory value. Now, different types of inventory items are certainly going to have a different cost in terms of carrying them. That means storing them, taking care of them, making sure they don't get stolen, making sure it doesn't go bad. And so a shortcut that a lot of people use is just simply to say the inventory carrying cost is a certain percentage of the inventory value. And in this case, they said it's 25%. Now I've got some lead time calculator over here, and this can be used, okay, to figure out how many days of lead time you need to get your items. And we have the days open, and then the daily usage, and this is the lead time. Okay, and we have the order points, and we try to figure that out. Now, over here in this example, now we're going to move from this area, this blue area, down here into the green part. This is the computation outcome area. You'll see the days lead times are all given. Now let's click for a moment. Let's go up here and go over to the formulas, and let's go in and look at the name manager. And we have two identified. Okay, the fixed cost, and we could just scoot this over. The fixed cost of ordering, and carrying cost is a percentage of inventory value. Now, fixed costs, we understand, we've run into that before. And when you order inventory, it doesn't matter if you order 1 or 1 million, typically it costs the same amount of money. So we treat it like a fixed cost. The variable cost in the equation is the carrying cost. And if you think about it, it is a variable cost. If you have a whole bunch of inventory, then you've got to have space for it. You might have to pay more insurance for it. You have someone has to deal with it, take care of it, etc. So just having it around, that's what carrying cost means, all right, is going to be more expensive. The less inventory you have, okay, the less space it takes up, the less amount of time you have to spend making sure it's not been stolen, broken, any of that stuff. So we have these two components. So if you really wanted to say what is the cost of inventory, okay, you could say, you could start with the fixed cost, and then the variable cost would be the inventory carrying cost. Now, that's from an EOQ perspective, okay? Now, if we talked about it from what we would call a supply chain perspective, that's a different kettle of fish. What we're saying there is, what will it cost to get this stuff ordered, okay, sent to us, and received by us, and then it's integrated into the inventory and it becomes a carrying cost, okay? So when you look at it from that standpoint, you've got costs all along the way, but the EOQ works from the assumption you've got inventory, all right, and you just want to know how much do I need to order. And these lead times that are here, that are listed, excuse me, you can see them, and the order points, those have all been determined by management as, and I think I had the formula over here, if I'm not mistaken, that you can look at. Okay, and you'll see on the lead time, let's just say that the lead time is L4, the daily usage times L5. Okay, and that's 51. So you get the order, and then you have the order point. All right. So we've already got these established here, and I would say this: all this stuff that's over here in this is pretty tough, for the simple reason that you have to. Really, the truth is, this is going to be based on historic data. This is going to be based on just the experience of the company. All right, so I wouldn't get too bummed out about that. But notice what we have here. Now I've added some formatting here to make it look nice. I've got the product number over here, and I have those product numbers, and it looks like to me I have them in, I've sorted them in descending order, starting with the lowest to the highest, and I've got the package description. What is it? How many have we got on hand? And how much do we have on order? And what we have on hand and on order gives us the balance available. Okay. Now, in truth, really what I should do here is put a $sign in front of the C. I got a little sloppy here, and a $sign in front of the D. All right, boom. And then I just drag and drop it down. And you can see that. So I'm going to go ahead and just save that. Well, I can't because it's up here as a temporary file with that. Nor do I have, maybe I have it on my desktop. Now, I think I have it on the desktop. Now, we're going to do the economic order quantity, all right? And let's look at what that comes to, what it is, all right? The equation for the EOQ is the square root of 2 times the fixed cost of an order, and that's over F11. And if you look at F11, that's the annual usage, okay? Divided by the inventory carrying cost is a percent of inventory value, and you'll see that we've got that defined, times E11, and E11 is the unit cost. So notice that the fixed cost of the order is here. We got the inventory carrying cost, the assumptions, so we cite them. We take the fixed cost times F11, which is going to be the fixed cost of the order. Okay, is over here, and then that's times F11, and F11 will be the annual usage, and that's divided by the inventory carrying cost is a percent of inventory. You see it right here, times E11. And that's the unit cost. And you might you may have to do a little bit of formatting with it. You could, I guess, improve it if you put a $sign in front of the S and a $sign in front of the E, and then just drag it and drop it. We'll just do that here. Once you've got that basic thing worked out, boom, and there you are. Okay, and we can look at just to check it, because these we should go from F to G, F to 12. So in this case, we go up here to be absolutely positive. I'm going to put a $sign in front of the row. That means I'm sticking with the row. Okay. And now I can come down. Well, let's back out of that for just a second. Well, let's see here. Let's take the $signs out. It may be because we've got these other fixed cells in here that it's just going to flow down naturally as we drag and drop. So we'll go ahead and get rid of that. There we go. Now we're getting F12. Okay, that works. Now, we have the EOQ, the economic order quantity, that is the right amount of inventory to order, so we don't have too much on hand or too little. And anytime we go below the order point, then it's time to order. And if you see over here in this column, reorder, okay, you're going to see a conditional statement. And hang on a second. Who's calling, please? Hello? Hello? Okay, I'm going to resume the sharing. And what we've got here is a formula. And I'm going to put my cursor and click inside the formula bar. And you'll see it's a conditional statement. And it says equal if J11, and J11 is the balance available, okay, is less than G11, which is the order point, then we will get the text message yes. We've got double quotes, YES, double quotes, and then comma, and then a double quote and a space, and then another double quote. So it says if we need to reorder, then yes. Otherwise, leave it blank. Okay. Now this isn't all that big of a deal because we've got 15 of these or 20 of these. But if you had 1,000 of them, it's a whole different kettle of fish. So so you'll want to use some conditional formatting. Okay. And we can go over here and click. I'll go back home. I'll click on conditional formatting. And I'll look at I'll come down and manage the rules part, okay? Let me see here, okay? Sure I get everybody here. And I'll click to see manage the rules. And what it says, if the cell value continues, if the cell value contains yes, the word yes, and notice the quotes, then we're going to use this format. Ink background with dark red text. And it applies to that array K11 to K22. All right, so we had talked about this some before, so there's really no big deal, but this also gives me an opportunity to show you, okay, a kind of an inventory dashboard, if you will. And certainly if I have the data fed in and I know the lead time, all right, and I use the EOQ, then I know how much I'm going to need to order. Now the key pieces of this, you've got to know what is the fixed cost, what does it cost us to order something? You have to determine how do we determine carrying costs? Well, the easiest way is to take a percentage of make a percentage of the inventory value. So if we have $100,000 worth of inventory, we figure it costs us $25,000 to keep it. So it's a percent, it would be 25%. Okay, and some things are going to be cheaper than others to store. You see, this is why we call it business problem analysis, and I like to show you examples like this because they help put some more meat on the bones that the text really showing you about building models in Excel may not give you. And then the lead time, okay, becomes a question of company history, policies of the vendors, a whole combination of points, and the order point. That's a whole different type of issue, okay, and then we can, and I have a little lead time calculator using GoalSeek over here. I'm going to click on data, okay, and I'm going to go to the what if analysis up here, and I look at GoalSeek. Now, what I can do if I want is use the GoalSeek tool in here, but we're going to use it. We've used it with break-even analysis, and we're going to look now at the EOQ, economic order quantity, and the EOB, the economic order balance, the economic order batch. And we'll see this here. I'm going to close this off, okay? And we're going to go get those files that we need, right? And so we'll go back here to the modules, all right? Now, while I'm doing that, I'm also going to go over to Vital Source so I can get over to the textbook. I'll go to my Vital Source bookshelf, okay? I'll put in my email. And I think we're good to go. There we go. And there's the textbook. And we were working on chapter 18, but this time we're gonna work on chapter 81. And so we're going to scroll all the way down here to chapter 81. And this deals with the economic order quantity and the economic order batch. And it has the formulas and some good verbiage for you to read. Okay? Now, I'm going to do this. I'm going to back over here, and I'm going to go to the files. Now, I know I'm going to need the EOQ file and then the contra TOQ, why they pronounce it like that, I'm not sure. And that's going to be in the chapter 81 practice files. So we go to the files, all right, and we'll find the companion content file 2. It's that, and okay. Here it is, Excel companion content 2 zip file. So I'm going to download that file. All right. And this, I hope, won't be 2 minutes to download it. I pray. And take it a minute to get down here. Hopefully it'll be quicker. And then once it pops up, I'm going to put it in my folder. All right. And it's ready for me to download it. And I'll put show on the shoulder. And I'm going to move this over and I'll diminish my browser for a sec. And you'll notice I put it over here. I've downloaded it several times. So I'm going to take this and put it here. All right. And now we're going to come over here and we'll look at the, I'm going to open this up and I'm going to go into chapter 81 Excel files. I'll find the 2 files, and these are in the practice files. And I'm going to copy this and paste it on my desktop. And then I'm going to get the second one, and I'm going to copy it, and I'm going to paste it to my desktop. And then I'll close these off. Now, just to be on the safe side, all right, I'm going to rename this right now, and I'm put Harmon case Harmon XLSX 7. Okay, and I'll grab this other file, and this is the EOQ file. and I'm going to rename it EOQ Harmon XLSX7. Okay. Now, let's pop back up here for just a moment and go over to the textbook and take a look at what they're giving us some input. And this is chapter 81. Okay. And they give us some information in these bullet points about a company, okay, that sells cell phones. Now, this first one is a company that sells stuff. The second is a manufacturer that produces stuff. And so when we look at economic order, we have to look at it from two particular perspectives. The economic order quantity typically is where I'm looking backwards to my vendor, the people who, my supplier, how much do I need to order from them? The economic order batch, that formula is where I'm looking forward to my customers. How much stuff do I need to make to meet their needs? Okay, and they have and they give us these questions up above, and they frame them that way. Okay, and they give us some information about the hazards of inventory or holding costs, plus the hazards that are faced by running out of inventory. Okay, and they mentioned the fact that Harris at Westinghouse Corporation developed this formula in 1913. Now that's a little over 100 years ago, and it has stood the test of time. And again, here in business problem analysis is just as we try to develop a template, like we did with cash flow or income statement and balance sheet. It's the same thing we look for. We look for models, mathematical models, or models out in science or wherever we can find them that we can use to understand a situation, or that we can use to do a computation that will help us make a decision. So we come down here, and as the authors in the text do a great job of showing us, and this, they're going to start here, okay, with the EOQ, and they give us an EOQ template. And notice that we've got K is the cost per order, H is the cost of holding one unit of inventory for a year, D is the annual demand for the product. All right, and you can see they show us, for example, here on the EOQ, it equals the square root of 2 times K times D over H. A little bit of a variation on what we had, but it produces the same number. Okay, and then we come to the total annual holding cost, and that's, and evidently they've created a name. Use the name manager, because I see this one ANNHC, which I think is annual holding cost, and then we have ANNOC, which I believe probably is annual order costs. Okay, and then we get the orders per year, okay, which is D over EQ, and D would be the annual demand for the product, and EOQ is what we compute up here, okay, and this would be the cell 5 in the order quantity. All right, so I'm going to diminish this for just a second, and I'm going to open up the EOQ. All right, and let's take a look at it. And here's the file. We have the cost per order. We have the annual holding cost per unit. And here we have the annual demand. All right, and we have the order quantity. Now let's look at that for a moment. And the order and this is the economic, or this is the EOQ, as they show us here in column B, cell 5. And that's the square root of 2 times K times D, 2 times K times D over H. Okay, K is the cost of ordering. And D is the order quantity, and H is the, let's see, H is our annual holding cost per unit. So here, the one variation they've done is rather than taking, they've gotten an annual figure for holding cost per unit. But you can see we've got that result. So now we'll click on it. All right. Now in the text, and we'll go back here for just a minute, they show us the formula. Okay. And that we would have to, we'd have 100 orders per year in order to meet that need. Now, and so we've answered that question is when the store orders cell phones, how large an order should it make? All right. Well, the order cost per year and the orders per year, okay, is, and that gives us a clue, and we'll try to answer that question. So, and the cost, and I'm up here at this first bullet point, and for when the store orders cell phones, how large an order should it make? And that's going to be the EOQ, and it should order 100, and it should order 100 orders per year. And I would bet you if I take the EOQ times the number of orders per year, I will get the annual demand. Well, let's go down and take a look at that Excel file and see. Okay, now we'll open it back up for a sec. And okay, it says it's already open. Let me close this off. And I'll find it here. And let's see, it says it's already open. That's strange. I don't see it there, but that's okay. All right, now we have 100. Our EOQ, all right, is 100, and our annual orders are 100. So the number we're gonna number we're gonna order per year is gonna be the EOQ times the orders per year, and that will give us $10,000. And for Saturday, my phone is really ringing off the wall. Let me pause the share for a second. Hello? 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 Okay, I'll resume the share. All right, now we're back. So the orders per year and the EOQ come up to for these folks 10,000, which is what we have in terms of the annual demand. Now they have a second tab here, EOQ protected. All right, and let's look at this for just a minute. Now what they've done here in terms of protected is these are just simply values. Now we've got this cell has a protected in it because it can't be changed. Okay, so the only things we can change up here are these three cells. These others are the ones that can be changed. This is where we're protecting the cells. And if I'm not mistaken, the authors talk about doing that. And we'll pop back up here. Okay. And they give us some text to look at. operation research, applications, and algorithms. And that's a good one. All right, now let's go back over here for a moment. And the protected cells, of course, that would be, we'll go back to the protected cells. And I'm going to change this to 20. Let's just see what happens. Cost per order. And the annual cost per holding is 40. And the annual demand is 15,000. And let's see what happens. And notice now, these figures. Now, what they've done here is they've protected these cells. These cells, okay, can't be edited. You can up here, but these rows are set up where you can't edit them. And the reason being, these are the variables that you want to put in, and the formulas are already built in here and are hidden. But you can see it changed as I went along, and that's just one of those techniques, if you wish, that you can do. Now, again, if any one of these change, it's simply a matter I plug it in and I'm good to go. And so this is an EOQ template that answers that question of how much are we going to order a year? Well, the annual demand is 10,000, so the order quantity should be 100. Because if the order quantity is 100, then the orders per year would be 100. Now let's see what happens. I'm going to change the annual demand from 10,000 to 20,000, and let's see what it does to the OQ. Okay. And so what it says is we're going to do 141 orders per year. Okay. And each time we're going to order 141. So and I'm going to take, actually this is these two figures basically squared. So this is going to equal, and I get the 20,000. You say, what's the point of here? Well, what I'm doing is I'm saying, okay, I can look at some things, and there's some things I'm interested in knowing. Now, I'm going to make the annual demand, okay, back to our 10,000, back to original value. Now, if I want to, I can use GoalSeek to try to find out what I need to do if I wanted to reduce the orders to 50 a year, if I had the capacity to carry and receive 2 times as much. You see, one of the things that you have to think about as you do this, and again, this course is about me showing you models and computations, but the other reason I have a great passion for teaching it is because I've worked in such a variety of situations that I've come to understand that these models have a lot of validity, because they work in so many different circumstances. If I have to handle 10,000 units a year, I have a demand of 10,000 units. Okay, and I order 100 at a time, and I'm making 100 orders per year. Then my question becomes, what would happen? How do I get this? How do I get this down to a point where I could order less? Okay, could I get the order? Could I get the order the numbers lower? And I could. All right, but I'm going to have to be able to receive, that is, has shipped to me, and to store and to handle twice as much stuff. I'll probably need more space, additional people, etc. If I want to come up with the having placing fewer orders. Okay, and let's look at this. Look at the equation. The orders are predicated by the EOQ. That's the orders per year. And we'll look at this. Okay, and we have an EOQ of 100, and we have a 2 times K, which is the cost per order, times D, which is our annual holding cost per unit, and our annual demand. So we can try to play some scenarios with it if we choose to do so, but that means we're going to have to do some work with our vendor to try to get that accomplished. All right. And if I want to reduce this to 50, that means the order quantity is going to have to be 200. Okay. And one way I could do this would be to take this whole thing, and I could take this, and we just try this, times 0.50. Let's just see what happens. And there it is. I get an EOQ of 50, okay? And I do 200 orders. All right. Now, let's talk about this for just a moment, because we've made a management decision. We want to slash our orders in half. And to do that, we said, okay, our economic order quantity, and we'll go back up here, is our assumptions up here about cost per order, annual holding costs, and the annual demand. And I'm going to say, okay, I want to order twice. I want to place twice as many orders as I did last year. Okay, because probably what that means now is I'm maybe going more towards what we would call a just-in-time inventory practice. Okay, so I'm down to 50. Let's look at my holding cost per year now is 500. The order cost is $2,000. Now let's take that back for a minute and walk it back to the original figure. My order cost is $1,000. Why? Because while the fixed cost, the fixed cost of ordering stays the same, okay, the variable cost does not. I'm taking in more inventory. All right, and let's look at this. The order cost is K, cost per order times 10 times the annual orders. So you can see I can come in here and do some projecting, play with it a little bit, and that's part of what this protected area is here. So let's say what is this? Let's say that we decide, all right. Now, right now we're spending, and this is why they gave us this protected area, so we can do a little scenario building. Let's say for a moment that I have, instead of an annual demand of 15,000, I decide I'm going to do a sale, and I'm going to make that 15,000, okay, times 1.5. Now let's see what happens. Oh, I've got some values in here because of those protected cells. Put this equal. There we go. Now our economic order quantity is 150. Okay. Our annual orders are 150. And notice I'm using this model that the EOQ and the annual orders squared give us the figure. And that's because if you look in that economic order quantity equation, we'll look at it back here, the EOQ, we're using a square root. So anytime we take the square root of two numbers, we get the number, right? If we square the number, we get the number squared. So we're working with ratios. There's a little bit of the math into this. Well, let's close this off. And of course, for XLS7, you could upload this. And I'm going to save it. And I'm going to save it on my desktop. And I'm going to put key. And I'll save it as a key. And it's there. And I'm going to go ahead and upload it. I'll let you see a little behind the scenes work that we do here. And so I'll go back over here into the files section of Canvas. And I'm going to upload that file. I'll find that key down here. There it is. It's uploaded. Now I'm going to come over to the modules. We'll come down here to the XLS7. And I'm going to add that file. And we'll do this here in the same minute. Looking at here, look for anything key. Here it is, the key. I'll add the item. And it's here. And I don't need, one of these I can remove. And so I'm going to take that key. Let's see how I do this. Okay. So I've got the example. I'll put the example up above. I've got the key for the OQ. And then let's look at the economic order batch. This is a different side of things. Okay. And I'm gonna rename this right now. Key EOB Harmon XLSX7. Okay. That way we can distinguish between economic order quantity, which is how much inventory do I have to add, do I need to order, and then we see the different side of this. We're looking now externally out to our customers, to our market, saying how much do I need to make to satisfy the demand of my customers. Now it's Saturday afternoon in the United States of America, and I can assure you that somebody somewhere is using one of these applications to either figure out what to order or how much to produce. They probably have somebody in a weekend shift, if it's a manufacturing facility, working on orders. They probably have an order specialist working on that type of thing. Now, there are a lot of amateurs out there today in the palaces of college football, from sea to shining sea, who are tailgaters. And last time, well, Ma, how much beer do we take? Well, we went through 3 cases last week. Okay, I'll take 4 this week. It's the Army game. And how many brats? Well, we went through 4 dozen. So let's get 5 dozen this. And a lot of that. I can tell you something. My dad, when he had his first 3 stores, here's how he did his inventory. He took out he took a notepad and he would walk around and he'd write down the order. And I said, "How do you do?" He said, "I know what I sell. I know what I need." And he didn't need computers. I wish I was. If I had 1/1000th of the brain power he had, I'd be a very smart person. Well, to make a long story short, let's open this up and we're going to look at the EOB model. Okay. And here we are again. We've got this cost per batch. This sounds very familiar to the cost per order. Okay. And we've got the holding cost, annual holding cost per unit. So every unit we have, it costs us $500 a year to keep it. We have the annual demand of 20,000. We have an annual production rate of 2,500. Okay, that's our production rate. Now, let's go here for just a moment and we'll go back up. And I'm going to go back over here to Vital Source and we'll look at this EOB. Okay, and D is the annual, and then we have R, which is annual rate at which the product can be produced. And they say, and they give us an example of IBM, and then they walk us down to the EOB, and they'll give us an equation. But EOB is the square root of 2 times K, the cost of setting of a batch for production, times D, which is the annual demand for the product, and R is the annual rate at which the product can be produced. Okay, because we have to know how much we can make, our rate. Okay, and that's divided by H, which is the cost of each unit in inventory for a year, times R, which is the annual rate at which the product can be produced, minus D, which is the annual demand for the product. So it's a little bit of a different critter, right? Now, part of the balancing act here, not only of the cost to order, okay, but also the cost to hold the inventory, and then how much can we make? So let's look at this here. They walk down, okay, and they'll walk us down to the answer. And the question that's posed to them is up here, and we'll pop back up here. The computer company produces 10,000 servers per year. They give us the cost to produce each server. When the plant produces servers, how large a batch should it produce? Now, let me stop for just a minute and expand a little bit on the text. If you're a management major, you should have had, or you will soon be taking, the production and project course. All right? When we talk about batch processing, what we mean is we make stuff in batches. There are 2 basic kinds of manufacturing operations. One is a batch, which takes orders and then fills the orders. The other is what we call a continuous, like an assembly line, where you're making one, maybe 2 things, depending on how many things you handle in that plant, and you make it till you're done. You don't take any orders. You have an order that comes to you from management upstairs that says, make this many cars. As opposed to, Marco's Pizza, that gets a phone call and says, hey, I need 6 cheese pizzas, blah, blah. That's the difference. Okay, so both of these are very, very useful tools. Well, let's pop down here and let's find out, when they produce servers, how large a batch should they make? They don't want to make too little, and they don't want to make too much. So I'll pop us down here and we'll go back to the EOB. I think I got it open already, and let's look at it. Here's the cost per batch. Okay. Here's the annual holding cost per unit. Here's the annual demand. Here's the annual production rate. And now we look at the batch size, and let's look at this. It looks familiar, hauntingly familiar, like, excuse me, hauntingly familiar, like the EOQ. And you're going to notice something, okay? On the EOQ or the EOB, we start the equation off with the square root function in Excel, okay? Now, if I want to see some more information, I'll just click here on the insert function, and it will tell me what this is. And it returns the square root of a number. And they'll even give you some help on the function. Away you go. Now, the square root helps us take numbers and wash them up a little bit, okay, and take them down to an essence. And that algorithm or that model says, here's something I'm going to distill it down and get the square root of it. Okay. Now, by the same token, if I square it, I'm back up to the number. All right. So we'll see the square root. The mathematics of this formula are out there, and they're pretty complex. So if you want to take a look at them, do. But it's really the theory behind this is really not for the faint of heart. That gentleman at Westinghouse who produced the EOQ in 1913 and we're in 2018 must have been pretty smart, because people still use that. So we've got the batch size, which is the square root of 2 times K, which is the cost per batch, times D, which is the annual holding cost, the annual production rate, times the rate. D is the annual demand, excuse me, and rate is expressed there, annual production rate, in numbers, and that's divided by H, which again we're back to the annual holding cost per unit, times rate, okay, minus D, the demand. So we've got the rate minus the demand. Now, so we end up with 115.470. So that's our economic order batch. Now, because we have that annual production rate thrown in there, we're not going to get just the square root to figure out how much we need to make. It's going to have to come up to annual demand. So we're going to come down here and we'll get the holding cost per year. And you can see that the EOB divided by the rate. And those are saved up in the name manager. Annual holding cost, I'm sure that's up there in the name manager. Yeah, it is. Annual batches times K. There's the annual holding cost plus annual the annual holding cost plus the annual order cost, and then we've got the batches per year. Now let's take this. I'm going to take equal the batches per year. I'll take that times the annual the batch size. And what I make, boom, I'll get 10,000. Now again, over in the protected area, they'll let you play around with some of this. Let's say if the cost of a batch, if the cost of per batch is 500, let's see what happens here. And notice something. If the cost per batch goes up, I'm going to make fewer batches, okay, with more batch size. Notice that the batch size went up and the batches per year went down. Let's go the opposite way, all right? We had 200, and let's say instead of that, it would be 100. Let's see what happens. Well, the batches per year goes up 22, okay? And the batch size goes to 81. Now, you said, well, other than just jumbling around the numbers and running your mouth, is this of any importance? Oh, yes, it is. This would be useful for me if, for example, suddenly I find out that my supply, the people who handle my shipping, all right, have said we're changing our routes and we can only come by you, we can only come by about we were coming 4 times a week. We can only stop twice a week now because you just don't bring it. You don't bring us enough stuff to carry. You say, do people? Yes, they do. The shipping companies can dictate to you how much you make per batch for a very simple reason. Unless you own your fleet, unless you own your own fleet of trucks or you have a railroad car of your own to get it somewhere, you'll take the deal. Railroad is even more of a precarious situation because so many people use the railroads as an inventory warehouse. They make the stuff and they throw it in a rail car if it's not perishable or something. They'll let it sit for a month or two, and then the people at the railroad will call and say, your time's up. Where's this headed to? And you tell them it's headed to wherever. Okay, and that way you let the railroad warehouse your stuff. Now, trust me, they'll pay you. They'll put your car or cars of stuff in a secure location, but they will charge you for it. But you can see how many of these kinds of dynamics we can run into and deal with it. Now I'll take this back to the regular, and you can see, and I'll take it even back further, where we had the demand for 10,000. What if the demand goes up? Now, if the demand goes up, all right, let's see what happens if the demand goes up to 15,000. Okay. I'm going to be sending my annual batch, and I'm going to be ordering 86 times a year. And I'm going to be shipping. I'm sorry, I've been ordering on EOB. It's shipping. I'm going to be shipping 86 times a year, or 87 roughly, and 173 units. Okay, and the annual holding cost I'll have to come back then and say, all right, if I'm doing this, I have a lot more. Well, the holding cost per year goes up. Right now, it's the order cost and holding cost are the same, okay, per year. And let's see what happens if I take that back, and they stay the same. And you can play around the protected cells if you care to do it. Well, now I'm going to save this file. All right, so I'm going to save it on my desktop, and I'm going to put it up here in the desktop, and this will be key EOB. I'll save it on my desktop. Yeah, I'll replace it. Oh, you're being naughty to me. Let me close that off. Go back down to my file. And I'm going to save this. I'm going to save it as on my and I want to save it as an Excel workbook on my desktop. Okay, and there we go. And took it back to that copy thing. Let's see where that's at. Okay. And I'm going to rename it. Now I'm ready to open this up. And we're good to go. Now I'm going to upload this. Again, another look back, behind the scenes look. And I'm going to upload the EOB. First thing I have to do is put it in the files. Okay. So I'm going to upload the key EOB on the desktop. All right. And I'm going to come now over to the modules. And you're seeing me do it. One should be crying to me, saying, "Oh, I can't find the file." Here it is. And I'm going to add it to this module. All right. And the key EOB. And it's added there. And now I'm just going to move it on up. Okay. Well, I grabbed the wrong file. Pointers. Okay. Let me grab this. There we go. Close. And we'll go up one more couple of rungs. Now, as you notice, this week we've looked at economic order, which is a type of optimum. We call it optimization. We're given our resources or sets of constraints. We do the best we can to try to figure out, well, what's the largest batch of stuff I can order, okay, and keep the ordering costs where they need to be, and at the same time balance that off with my inventory holding costs, okay? And then we saw the same thing with the batch in terms of how much stuff should I keep on the floor and how much should I send. So when I was talking about the EOB, the economic order batch, when I was talking about ordering, I really meant producing and sending. So there they are. They're both up there for us to see it. And you'll have those to be able to upload for XLS7. And we've looked at the hardware nuts case, which deals with that. And so we've taken a trip through break even and optimization, a little bit of optimization land. And away we go. And then, of course, next week you'll have the few texts. So everybody, and I will see you next week. And you have these you can upload for XLS7. Any one of these two would be fine. The EOB or the EOQ, I don't care. And then you have that example of hardware nuts. As I mentioned there, it's example for XL7, okay? All right, everybody, I'm going to stop the share and then stop the recording. And this is going to be BISS 1123, part 2 of the September 20th class. We'll stop the share.